So I was just explaining, okay, our special polynomials that we went back to page 10 and took a look at example C, which showed us a conjugate. And so we can see that we're circling back to our definition of a conjugate. A conjugate is two binomial factors, okay, whose product ends up, right, that middle term falls out, and it becomes what we call a difference of squares. A difference of two squares. So here's our example. So when we FOIL this, okay, we end up with x squared plus 2x minus 2x, okay, minus 4, which is the same as x squared minus 4. Okay, so a conjugate always produces two terms. Remember when we did a binomial and a binomial? We always found that normally, when you multiply them together, we end up with three terms, except for this special case of a conjugate, which gives us only two terms. So what we're going to be doing, right, so this is us expanding, okay, and getting to our difference of squares. Now we want to, like, undo that. We want to go the other way. I'm going to give you a difference of squares, and I want you to tell me what the conjugates are. Okay, so here, okay, a difference of squares. So a difference of squares has this form. The first term has to be a square. Okay, it can be a number, it can be a variable, it can be a combination of both. Okay, and we'll show you lots of examples so you know what I mean. Okay, it has to have a minus sign in between. Okay, favorite common mistake, my favorite like test question, right, is to put two squares but put a plus in between and say, please factor this. And people are like, oh, squares, I remember, you know, and then they go to difference of squares, but they forgot to realize it has to be a subtraction sign between the two. Otherwise, it doesn't count. Otherwise, it's not this special case. Okay, so what happens is when you find out that you have a difference of squares, you can square the first term, okay, and you can square the second term, and then you just do one bracket with those numbers plus and one bracket with those numbers minus. Okay, so here's the step-by-step, and we'll do it with an example. So it would be really handy, okay, I'm going to write it here. Okay, it would be really handy if you don't know your let's even say your first 10 to 12 perfect squares. Okay, what do I mean by that? I mean, like, if I go 1 squared, 1. Okay, and then I'm thinking 2 squared. Okay, 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Okay, you need to know those numbers. Okay, so you would want to, maybe you could write it down on the side if you need a place to look, but you're looking, so these are the numbers you're looking for. These ones should, like, go ding, 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 something's going on here. 1, 4, 9, 16, 25, 36, okay, that's 6 times 6. 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, and 12 times 12 is 144, okay? And sometimes you'll see 13 times 13, 169. Okay, but beyond that, okay, these are the recognizable ones, okay? So you should be, okay, being able to recognize when there's a perfect square, right, that you can take the square root of it. Okay, the other ones that you want to, when we're talking about a variable, okay, x squared is a perfect square, right? So if I took the square root of it, it would just be x times x, right? Okay, so this, like, this would turn into x times x. Okay, if it was x to the power of 4, this is also a perfect square, right? Because this becomes x squared times x squared. Okay, so they're also going to give you some variables that are perfect squares, and it just depends on the exponents. Is x to the power of 3, is that a perfect square? No. Okay, it has to be an even number. What about x to the power 6? Okay, if I did x to the power 6, okay, my exponent laws say that I add my exponents, so I would have x to the power 3 times x to the power 3. So x to the power 6 would be a perfect square. Okay, so any even number of exponents will give me perfect squares. Okay. All right. So let's take a look at this. So we see x squared, right? Even exponent, we're like, yes, this is a perfect square. 25, is that one of my perfect squares? Yep, absolutely, okay? And is there a minus sign in between? Yes, there is. So this is my special case of perfect squares. So what you're going to do is you're going to, okay, whether you need to do it visually and write it in or whether you can do it in your head, you decide where you're at. I'm going to show you all the steps. Okay, I don't necessarily have to see all the steps if you're good with doing the square root in your head. But this is what we're doing. Okay, we are literally taking the square root of both of these terms. Okay, the square root of x squared is x, and the square root of 25 is 5. Okay, so then what we're going to do is we're going to make one factor, okay, the sum, and the other factor, the difference. So what that just means is we're just going to pop it in here. We're going to make one the sum, so one is plus and one is minus. Okay, so this is our final answer. So I'll do a couple through for you. Okay, so a squared minus 4. So right away you see an even exponent, you're like perfect square. Check. 4. 4 on my list? Absolutely. What's the square root of 4? 2. I'm glad you all answered that. Okay. So then, so for some of you, if you need to, remind yourself that we're taking the square root of both terms. Okay, which is a and 2. Okay, and then we're just putting in one's plus and one's minus. If you're good with doing that one in your head, you don't have to show me the square roots. Okay, you could go, like if you look at this and you're like, oh, now we're doing a combination. 9. Is 9 a perfect square? Yep. Okay, is x squared a perfect square? Yep. Is 49 a perfect square? Yeah. Okay. Okay, you can go straight to 3x plus 7, 3x minus 7. Okay, if you're not sure where I got the 3x from or the 7 from, then I want you to go back to this. Take the square root of this and the square root of that. The square root of 9 is 3. The square root of x squared is x. The square root of 49 is 7. Okay, and then you can put these in, make 1 plus, make 1 minus. Okay, anybody else loving difference of squares? Like, it's a nice way to factor. I like it. Okay, so now, okay, just like before, we come up, okay, we see two terms. Okay, we start to get excited because we're thinking difference of squares. But don't forget our chart. Okay, our chart said that we always start at the top and we always ask ourselves, can we take out a GCF? Okay, because I look at this and I say, oh, wait a minute, 2 is not a perfect square. 50, 50 is not a perfect square. But 2, okay, I can take the greatest common factor of 2 out. Okay, so if I take the 2 out, I'm left with a squared minus 50 divided by 2 is 25, b squared. Do I now have difference of squares? Absolutely, okay? I can take the square root of a squared. I can take the square root of 25b squared, okay? And I can end up with a plus 5b, a minus 5b. Okay. All right, this one, okay, is x to the power 4 perfect square? Yeah, because it has an even exponent. How about 1? Is 1 a perfect square? Is 1 on our list? Yeah, it is. Okay, 1 times 1. Okay, so then that means I can do this as a difference of squares. Okay, so I take the square root, so I end up with x squared plus 1. Okay, x squared minus 1. Are we done? Like, we did the difference of squares. Okay, but we always have to look and see if any of our factors can be factored again. So sometimes that happened when we did grouping and like our leftover factor ended up having a greatest common factor that we then had to take out. This one, even though I did difference of squares, look at this. This one is a difference of squares again. Okay, because I can take the square root of x squared and I can take the square root of 1. Okay, now is this one a difference of squares? Like the x squared is a square, 1 is a square, we just said that. Okay, why can't I not do anything with this first factor? Yeah, it's plus. It's not a difference. So this one is the x squared plus 1 is as far factored as I can go. Okay, I can't do anything more to that one. However, I can still do this one. Okay, so what's the square root of, okay, what's the square root of x squared? It's x. The square root of 1, okay, is 1. So I have an x plus 1, and I have an x minus 1. Okay, so maybe star that one, because it's a favorite. Okay, I will always try to, okay, put something like that on so that I'm looking to see if you notice that you can continue factoring. Okay, I want to see if you've noticed that. All right, so this is that diagram we've been talking about. Okay, so when we have our question, first thing we do is look for a common factor. If you can take one out, great, you take it out. Okay, if not, that's fine, you keep moving down. And then you look at how many terms. Okay, if there's 2 terms, okay, could be a difference of squares, double check. Okay, if it's not a difference of squares and we've already taken out a greatest common factor, we're done. Okay, if it has 3 terms, okay, then we check, we say, is it simple trinomial, complex trinomial? Okay, which one is it? If it has 4 terms, okay, then we're just going to be doing grouping. Okay. All right, and so here we are, simple trinomial, okay, complex trinomial, where we do that breaking apart of that middle term, where we have to do product sum and grouping in order to get to the final one. So this one, this decomposition, certainly takes the most amount of effort. Okay, so make sure that you're really solid on being able to use all of them, okay, but especially that decomposition, because then that means you understand greatest common factor and grouping as well. So always check, okay, to see if any further factoring is possible. You know, when your numbers come together, can you still take out a greatest common factor? Did my difference of squares lead to another difference of squares? Like that. All right. Factor the following expressions. Identify the method that you use to factor. Okay. Okay, someone give me some advice. What should I do for A? Okay, I have 2 terms. Yeah, we always start with GCF. Okay, is there a common factor here? Sure thing. I can take a 3 out of both, and I'm left with x plus 4. Okay. B, I can count that there's 4 terms, so I'm going to be doing grouping. Okay. And now I'm going to say, what's the common term here? Okay, I can pull out an x squared. Okay, so for those of you that find this helpful, okay, there's my x squared, and then I'm left with 5y minus 1. Out of this one, okay, there's nothing obvious between a 5y and a 1, so the only greatest common factor I can pull out is a 1. Okay, there's nothing else that's common. So I can pull out a 1, and I'm left with 5y minus 1. Okay, now my 2 brackets match. Okay, so I can pull the 5y minus 1 out in front, and then I have my leftover. Ooh, okay, I've got an x squared and I've got a 1. Okay, those are perfect squares. Can I continue factoring? Okay, is it a difference of squares? No. So this one is done. Okay, I can only continue factoring if it had been a subtraction. Okay, this one has 2 terms. Is there GCF I can take out of it? Okay, no, there's no GCF. Okay, there's 2 terms, so let's see if we can do difference of squares. Okay, is 4 perfect square? Yeah. X squared perfect square? Yeah, how about 1? Yeah. So if I take the square root of both of these, okay, I end up with 2x plus 1 and 2x minus 1. Okay. I'm going to do 2 more with you, and then I'm going to have you do some on your own for a few minutes. Okay, this one, okay, we first go through GCF. Okay, nope, there's no GCF that I can take out. It has 3 terms, so then I just double check. Is this a simple trinomial or complex? Okay, because there's no number in front of x, well, technically, guys, there is a number, right? It's 1. So because my a value is 1, okay, the number in front of x, that means this is a simple trinomial. I can go straight to product sum. Okay, I suggest that we pay attention here. Okay, 2 numbers that multiply to give me negative 15, add to give me negative 2. Okay, so 3 and 5 are kind of the ones that work with 15. Okay, and if I have a negative 2, I'll want a positive, a negative 5 and a positive 3. Okay. So then, once I have these, I go right to factored form. X minus 5, x plus 3. Now, E, okay, I first pass it through my greatest common factor filter. Can I take a GCF out? No. Okay, it has 3 terms. There is a number in front of the x squared, so that means it's complex. Okay, move up here, please. No. Yeah. Okay, thanks. All right, so in this case, right, if we have a complex trinomial, okay, we're going to do product sum first and then grouping. So our product is, we're multiplying the negative 4 by the 3. Okay, so the first one and the last one to give us negative 12. And our sum is negative 4. Okay, what 2 numbers? Okay, so we kind of do that game. We have to figure out the positive. What 2 numbers, when I multiply them together, give me negative 12. When I add them, give me 4. Okay. So when we're looking at 12, we have like 1 and 12, 3 and 4, 2 and 6. Which ones did you choose? Sure, can you just wait till we're done with this? Okay. Can you give me the factors? What do you think? Yeah, absolutely. Okay, so now, now that we've done product sum, now we break apart the middle term. Okay, so we have to take this, I'm just going to do it in another color, just shows up really well for you. Okay, we're going to break apart my negative 4x, and we're going to switch it with a negative 6x and a positive 2x. Okay, I'm kind of running out of room here. There we go. Okay, so our 3x squared stays the same. Now I'm going to break apart this. I'm going to have negative 6x, positive 2x, okay, and then my minus 4. Now I can do grouping. Okay, and I can take out 3x here. I'm left with x minus 2. And my greatest common factor for these two is a 2, so x minus 2. Okay, my brackets are both the same, so I can pull them together. And then my leftover factor. Okay. So I'm going to give you a few minutes. I want you to do, okay, these next 4. Right, and then we'll pause. Good luck on the game. The homework that's listed on the lesson. Yeah. Okay, we're going to finish up our notes, make corrections as you need to, or add some comments to yourselves about maybe what step you could take, or maybe something that you've forgotten. So for this one, okay, I look at those 3 and I right away see that they're all even. Okay, Xavier, homework?
Is that the one that we can try to open one?
No, that was like 2 days ago. This one, okay, page 194, it's on the bottom of your lesson. Okay, textbooks included.
All right.
Okay, that's part of your homework check tomorrow.
Alright.
Okay? Great. I'll see if I can give you guys some class time at the end to start some homework questions. Okay, so for this, the first thing that you need to realize is, okay, you can take out a greatest common factor. Okay, plus 4z plus 1. Okay? So it helped a little bit, but it's still a complex trinomial. Okay, we still have to do decomposition. Okay, so in this case, we're doing product sum. Okay, two numbers that multiply to give me 4, add to give me 4. Okay, we should be like, oh, 2 and 2 works well. So we have to break apart this middle term. Okay, this 2 just continually lives outside of the brackets. It just sits out there until the very, very end. Okay, so in this case, we have to go 4z squared plus 2z plus 2z plus 1. Okay, then we do grouping. Okay, with all those brackets, it starts to look a little squishy. I get that. Okay, but okay, that's why I try to use different colors. So from this group, okay, I can pull out a 2z, and I'm left with 2z plus 1. Okay, and then from this group, I have a 2z plus 1. I can't pull anything out other than a 1. Okay, and then I end up with 2z plus 1. Okay, so then I write this, and I have 2z plus 1, and another 2z plus 1. Okay. Okay, here's another example. First I take it through my greatest common factor filter. There's no greatest common factor, so then I can do decomp. So I'm going to do product sum. I'm going to do 4 times 2 gives me 8. And then I need a sum that gives me positive 9. Okay? Just because I'm running out of room, I'm putting my factors down beside here. Okay, so if I do 8 and 1, when I multiply them together, I get 8. When I add them, I get 9. Okay, so this breaks apart. This becomes 2x squared plus, okay, we'll do 8x plus x plus 4. Okay, and you can do your grouping. Okay, and then you're looking for greatest common factor out of each group. Okay, so the things that are common here, we have a 2x, and we're left with a 2 plus 4. There's nothing in common in that second group other than the number 1. Okay, and because we're doing grouping, we have to pull out what we can, even if the only thing that we can pull out is a 1. Okay, so we do plus 1, and then we end up with x plus 4. So we're looking at x, so this is 2. Okay, so now, okay, my two brackets are the same. I can bring them together here at the front, and then write my leftover factors. Okay. This next one, I look at it, all the numbers are even, so I know I can take out a greatest common factor of 2. So I'm left with a squared minus 8a plus 7. Okay, this time, the greatest common factor did reduce my trinomial to a simple trinomial. Okay, so I can just do product sum and go right to my factored form. Okay, I don't have to do the grouping and everything else. Okay, so my product is, okay, my product is 7 and my sum is negative 8. Okay, so two numbers that multiply to give me 7, but when I add them together it gives me negative 8, so probably negative 7 and negative 1. Okay, so my two numbers, negative 7 and negative 1. And so I can go right to factored form. That 2 still stays out there. It still lives outside of the bracket. Okay, it's one of my factors, but I don't need it for this. I can go a minus 7 and a minus 1. Okay. Now this one, okay, I should look at it and say, ooh, there's 2 terms, there's subtraction side, I'm getting excited. Could be a difference of squares. Okay, and it is. The square root of 9 is 3. The square root of x is x. Square root of 25 is 5, so one's going to be plus 5. Okay, and then the other is going to be minus 5. questions on those ones? Okay, let's continue on. All right. So this one I see, is there a greatest common factor? There is not between 3, 5, and 12. So all that I have to do decomp. Okay, so I start with product sum. Negative 12 times 3 gives me negative 36. And the sum is negative 5. Okay, and I know that if I do 9 times 4, I get 36. And so if I do negative 9 and positive 4, and I add them together, I'll get my negative 5. So I'm going to break apart this middle term. So I have 3x squared minus 9x plus 4x minus 12. Okay, then I'm just going to group these. And I'm going to have to do my greatest common factor. So 3x, x minus 3, and then I can pull 4 out, and I'm left with x minus 3. Okay, now that my brackets are both the same, I can pull those together. X minus 3, and then I get a 3x plus 4. Okay. A, there's no number other than 1 in front of x squared. Okay, so we can do a simple trinomial. We can go right to product sum. Oops. Go, product sum. And my product is negative 18. My sum is negative 7. Two numbers. I'm thinking 9 and 2. Okay, so how about a negative 9 and a positive 2? Okay, and because it's a simple trinomial, I can go right to factor form, x minus 9, x plus 2. L. L is interesting because you look at it and you're like, ooh, I think it's going to be a perfect or a difference of squares, right? Because there's two terms, there's a subtraction. However, okay, 2 is not a perfect square. Certainly 2 is not a perfect square. So the key to this one is you take out a greatest common factor and hope that you get your difference of squares once you take out a greatest common factor. So if I divide both of these by 2, okay, then I do indeed get, okay, my x squared minus 36. Okay, this is a difference of squares. So I can say 2x plus 6 and x minus 6. Because 6 times 6 gives me my 36. Okay, I'll give you a second to jot those down. Oh, the question actually asked, okay, let me reread my question. It wanted me to factor, and it says identify the method that you use to factor. I need you to be able to identify it, okay? I know for sure that there's a question similar to that, either on the upcoming quiz or on the assignment. It will ask you to factor and then just identify. So what I'm looking for, I'm just going to move this up. Okay, I would want for you to be able to look at this and say, okay, I took out a GCF. Okay, you can short form it. GCF, that's fine. Your method, GCF. This one, okay, your method was grouping. Okay, this one, difference of squares. If you want to shorten it, you can say diff, okay, of squares. That's fine. Or you can write out difference of squares. Right, for D, this one was a simple trinomial. So we did the product sum method. Okay, this one we use decomposition. Okay, if you want to just do decomp, I'm okay with that. Decomposition. Okay, if you want to spell it out, that's how you spell it. Okay. Now this one, okay, if you do two things, then you need to write that you did two things. So first we did a GCF. Okay, then we did decomp. Okay, I just need for you to identify the different methods that you're using, okay? So then, we'll put it back up here. So then this one was also a decomp. Okay, this one was a greatest common factor, okay, and then product sum. Okay, this one was a difference of squares. Okay, and then this one was decomp as well. Okay, this one was product sum. And we did a GCF and then a difference of squares. You know, that's a lot to write. I will move the screen back here for those of you who are writing furiously. Okay, I just want to go over the last couple examples, okay, so that you're all ready for the next couple days. Okay, there's just a couple more examples on the next page. Okay, the polynomial expression can be written in this form. Okay, the value of 8 plus b. Okay, so they're saying that when we factor this, we'll find out that both factors are exactly the same. Okay, because remember what this means. Ax plus b times ax plus b. Okay, so when we factor it, we better have both sets of our factors being the same thing. Okay, so in this case, we'll have to do decomposition because our a value is not equal to 1. Okay, so there's a number in front of the x squared. So what we're going to do is we're going to do product sum first. So two numbers that multiply to give me 9, add to give me 6. Okay, it looks like 3 and 3. So then I'm going to go 9x squared plus 3x plus 3x plus 1. And we're going to group them. Okay, and we can pull out 3x. Just clean that up a little. And we're left with the 3x plus 1. And then same thing, there's nothing obvious to pull out, so the only thing that we can pull out is a 1. And we're left with 3x plus 1. Okay, so there we go. Now you can see that our factors are exactly the same, just as we hoped they would be. So then we look at our form, okay, and we notice that, okay, a must equal 3 and b must equal 1. Okay, this is my a, and this is my b. Right, and it wants us to the value of a plus b, so 3 plus 1. So our numeric response will be 4. To that one. All right. So this is one of those questions where, okay, you would need to factor the expressions in order to tell how many Rachel did. So this one is like an error analysis. Okay, it's kind of taking the idea of not just doing your work, but seeing if you can catch somebody else's error. It does take a little. Factors occur, solutions are recorded next to each expression. Okay, well some of these we can take a look at, like this one, expression 2. Is this factored correctly? Why is it not? Could we continue going on? Yeah, it's a difference of squares still. Okay, this one's incomplete. Okay. Okay, so just for I'm just kind of looking at the time here. Okay, I want you guys to work on this one. Okay, but I'm just going to let you know, okay, how many did she actually factor correctly? There's only 1, so see if you can find the 3 that she did incorrectly, okay, and be able to identify those. Okay. Now I gave you some extra class time to do all the questions, right, with a friend from the notes. If you still need to write those, let me pop those back up, okay, because I know that it was a lot of writing. Okay, that means you have homework tonight. So you need to go on Google Classroom to pull up your textbook. Your homework is on the bottom of your lesson, okay, page 194. Okay, it's just 8 A's, 10 A and C, 13 A and C, and 18. So it's only 5 questions. Okay, but that's going to be part of tomorrow's homework check, because tomorrow's Thursday. So at the beginning of class, you're going to come in, you're going to hand in your homework. Okay, I'm going to give you the quiz, and we'll see how things are going that way.